Right, now for question 8, it's about the spider. So what I have is, I have my gear, let's say gear A, and again gear B, and I will ignore all the rest. So basically my spider is this arm here, okay, and then it goes there, but I'm just worried about this arm here, which length, as you can see, is going to be 2r, or if you want, 0.08 meter. Okay, that's it, that's the spider. Right, so now let us do the analysis for the spider. Basically, what I can see is that this point over here that I marked there on gear B, okay, is fixed. So that point is fixed to B. So it means that the velocity of the spider over there is the same as the velocity at B. So I'm going to do the study again on gear B, exactly the same thing as before. So what I will do is I will sketch my gear B. I will decompose this into a pure translation plus a pure rotation as always. So translation, and pure rotation. And now at gear B, what does it happen? So I have point A on gear B, which I'm talking about this point over here. So these are the 2 points I'm going to work with. It's this point and that point. Okay, so I'm going to call this my point A, which is the connection point between A and B. And I know that the velocity is VA like this. Okay, this is what I know, right? On the other hand, I know that from before the velocity at E is to the left. Anyway, I don't really care about this. I don't know, it is an unknown. I can put it either to the right or to the left. So if I don't know, I will put it to the right just to be positive. So I will assume it is to the right, it is an unknown, and I'll call it VB, okay, at the center. This is my VB, okay? Now, pure translation, I'm going to do it with A again for a matter of convenience. So rotation is going to be about A for a matter of convenience as well. So VA here, and here at this point I have here my pivot point. Okay, so I'll have here, how is it going to be the rotation? So I determined that omega B from before is going to be anti-clockwise. Okay, so it means that here this point will have to rotate with respect to A in the anti-clockwise direction. So this is going to be VP with respect to A. So this is my diagram. I now look only to this equation, and what I do is VB, X components, I don't need to decompose because they are all horizontal. VB, which is positive, is equal to VA, which is positive, minus VB with respect to A. At the same time, VB with respect to A is equal to omega B times R, because R is this distance over here. This is R, okay? So I just replace this there. So what I have is VB is equal to 1.0053 minus, okay, minus omega B, which is 20.42 times 0.04. And this is going to be equal to, and I'm going to my calculator, 0.0053 minus 20.42 times 0.04 yields 0.1885 radians per second. Okay, that's what I have, VB. Okay, and sorry, meter per second. This is my VB. So now with this value of VB, I can just go to my spider, which is this spider. All right, this is the length of my arm, which is 0.08 meter, and I know that the velocity at this point is VB, which is the velocity of the spider at that location. So what I know is that the velocity of the spider is equal to omega s times 0.08, which means that omega s is equal to 0.185 divided by 0.08 gives 2.356 radians per second, and this is going to be in the clockwise direction. Again, another mistake. This is the problem. I just messed up with the directions here. Okay, but let's see if the result is correct over there. So my guess is this. So the frequency is going to be, so I know that omega s is equal to 2 pi fs. So this means that fs is equal to this value divided by 2 pi. So this is divided by 2 pi. I obtain 0.375 hertz, which is exactly what is here. So yes, I just messed up with the directions, so I'll have to change this here as well. And this is the solution I will upload now online so that you have the correct solution. I do apologize for this mistake with the directions in the answers, but other than that, the problem should be now straightforward.